Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing how to convert a floating point decimal number into its hexadecimal equivalent. So as we discussed in the previous lectures, a hexadecimal number system consists of 16 different digits to represent the decimal numbers ranging from 0 to 15. So the numbers ranges from 0 to 9 and from A to F. So now in this lecture, we are discussing how to convert a floating decimal into a hexadecimal equivalent. So consider an example. The example is 2048.10 to the base 10. So here, as we discussed in the previous lectures, a decimal or a fractional number has two parts, a decimal part or a whole number part, as well as a fractional or a point part. So the conversions are done in two different steps. In the first steps, consider the whole number portion, and after conversion, consider the fractional portion. In the whole number representation, consider this number 2048. While converting this decimal number into its hexadecimal equivalent, what we have to do is continuously divide this number by using the base value 16 until the quotient will become 0. So 2048 is continuously dividing by 16. So 128. So we can tell 128 into 16 will be 2048. So 128 into 16 will be 2048. That is 128 will be the quotient with a remainder 0. And when this 128 is divided by 16, we will get 8 times 16 will be 128 with a remainder 0. And when this 8 is divided by 16, 0 will be the quotient with a remainder of 8. And finally, the answer will be taken in the bottom to the top order. So the equivalent of 2048 is 800. So we can represent it as 800 point. So in the second portion here, the second portion or the rest portion is 0.1. 0.10 can be represented as 0.1. So what we have to do is multiply the 0.1 with the 16. Multiplying this fractional portion with the radix value 16. So 0.1 into 16 will result in 1.6. Here again we will get a fractional portion. In this fractional representation or in this floating point representation, consider the whole number portion into the result portion. Here the whole number portion is 1. This 1 is taken to the result portion, and the rest of the fraction is 0.6. 0.6 is multiplied again with the 16. So this 1 can be represented into the answer portion. So this 1 is taken into the answer, and the rest of the fraction is 0.6 is multiplied again with the 16. So 0.6 into 16 will result in 9.6. So this is 9.6. Again, the whole number portion is taken to the answer part, and the rest is 0.6. 0.6 is multiplied again with the 16. When 0.6 is multiplied with the 16, again we will get 9.6. So 9 is taken to the answer, and the rest is taken to the multiplication step. So when we multiply, they continuously go into an unlimited number of steps. So we can stop by 3 points. So the answer of 2048.1 is equivalent to 800.19 to the base 16. So the decimal number 2048.1 can be represented in hexadecimal as 800.199 to the base value 16. So this is how we are converting a decimal fractional number or a floating point number into its hexadecimal equivalent. So my dear students, consider one more example, and the example is 160.4 to the base 10. So in the first step, consider the whole number portion. The whole number portion is 160. Continuously divide this 160 divided by 16 will result in 10 times with a remainder 0. When 10 is divided by 16, we will get 0 with a remainder 10. This 10 is represented as A, which is equal to A. So the final answer will be A 0.10 In the second portion, we have to consider 0.4, and this 0.4 is multiplied with the radix value 16. So 0.4 into 16 will be 6.4. So this 6 is taken to the result. 6 is taken to the result portion, and the rest of the fraction is again multiplied with the radix value 16. So again 0.4 into 16 will result in 6.4. The 6 is taken to the result portion, and the remaining portion is considered again for the next step. Again we will multiply 0.4 into 16 will also result in 6.4. That 6 is taken to the result, and this step will continue in a numerous number of times, and we can store by 3 precise decimal points. So the number 160.4, the decimal number 160.4 can be represented in hexadecimal as AO.666 to the base 16. So this is how we are converting a decimal fraction into a hexadecimal equivalent. So my dear student, consider one more example. The example is 1024.5 to the base 10. So here we are considering the whole number portion 1024, and this 1024 is divided by 16. We will get 64 times. We will get 64 times with a remainder of 0. When this 64 is divided by 16, we will get 4 times with a remainder 0, and 4 is divided by 16, quotient will be 0 with a remainder 4. So the final answer will be 400 point. In the second portion, consider 0.5 into 16. So when 0.5 is multiplied by 16, that will result in 8.0. So this 8 is taken to the answer portion, and the remaining portion is 0.0. That is 0 into 16 will result in 0. So here the step is stopped in the first step itself. So the final answer is 400.8 to the base 16. So the decimal number 1024.5 is equivalent to the hexadecimal number 400.8. So my dear students, hope you had understood this topic. So my dear students, kindly go through this assignment question. The question is to convert a decimal number into its hexadecimal equivalent. The numbers are 276.11, 310.23, and third one is 512.111. So convert this decimal number into its hexadecimal equivalent numbers. So my dear students, in the upcoming lecture, we will discuss how to convert a hexadecimal number into its decimal equivalent. See you soon. Until then, goodbye. Thank you and all the best.